Hello everyone, this is Anil and you are watching the YouTube channel Neelkamal Classes. So I welcome you all of you to in my YouTube channel. If you are new on this channel, then I request you to subscribe the channel, like the video, give your comment, and if possible then share this video with your friends. So in last class we have studied Lagrangian Dynamics. We did not study any of the concept, but we have introduced the Lagrangian Dynamics. So today we are going to start what is means. We will start with basic things. So in Lagrangian Dynamics we deal with the motion of a particle. How it means. So for that one we will see fundamental things. So to see that particle, we need let me take this is particle. So first of all we will see how to locate, how to means that how to can we observe the motion of a particle. So for that one we should know the position of a particle. So how can we define a particle? The first thing is that. So for that one we use one term that the coordinate system. So what is coordinate system? Coordinate system is something that define a particle, position of a particle, where it is located and how its location or position change according to time. So there are different type of coordinate system. So for 2D rectangular coordinate system, Cartesian coordinate system. If we go for 3D then spherical coordinate system. So let me see this particle is 2D motion. So for defining, then if I to show that system, then if it is in 2D motion, then it is like this. So this is my xy and then so this is position. So in 2D, if I want to show a rectangular coordinate system, then how can I show this position? So for that one we know, mostly we know that what else do we do? For that one we will make perpendicular on this one and perpendicular on this one. Coordinate, y coordinate and x coordinate. So let me take this is x1 direction and this one y1 direction. This is our position that to 0. So if I want to show that position of a particle on this rectangular coordinate, then I can show that the position of a particle is x distance from that on x-axis and y distance is y1 distance is in from y1. So for showing that I can write x1 and y1. This is the position of a particle. Similarly, if I want to show in cylindrical coordinate system, then in that one we use that r and theta. So for that, let me take position is and origin. We will connect it, and that is r. And theta is this theta we use. And so what is your in cylindrical coordinate? What does you see that the location of a particle is r distance from the origin, and it's making theta angle with x coordinate. That's axis. So this is coordinate called cylindrical coordinate, and this is rectangular coordinate. So and both are same, showing that same thing, same particle, same position, everything. So pakka they will be having some relation between them. So what is the relation? For showing, we can show like this. This is if I consider it a rectangular, then this y distance is same y1 here. So now let me see. So if I want to find relation between this one and this one, because this is a part of rectangular coordinate, this is part of cylindrical coordinate. So there is some relation between that. What is that? If I take it a triangle A, B, C, and this angle is theta, then if I see cos theta, so what is about cos theta? In this one, if I show cos theta, that angle is cos theta. So cos theta will be AB divided by AC. AB divided by AC, or that is nothing but R. For x1 is equal to, we will got R cos theta. Similarly, if I see sin theta, then sin theta will be our BC. Sin theta will be BC divided by AC. So BC is here y1 and AC is R. So y is y1 sin theta, R sin theta. So this is the relation between them. And This is the theta, R and theta, all these things. If I want to show, see that make further more easy or other way, then if I means let me see two. This is called equation number 2 and letting this is equation number 1. Now if I will use the Pythagoras theorem here, then can I write like this? R square will be equal to x1 square plus y1 square. Can I write? This one means the AC square will be equal to AB square plus CB square. AC square is equal to AB square plus BC square. So AC square is equal to R, and AC is equal to R, AB is equal to X1, and BC is equal to Y1. So I don't know. So I can, if I move, really I can write it like this. So this is for the 2D motion. What if I go for 3D motion? Then this is very easy. 2D 4 we can do, but in 3D you will be finding some difficulties. So let us see how can we define the position of a particle in a 3D motion. So I am taking a particle in a 3D motion, let here its position, and if I want to require 3D motion, then I require 3 coordinates. So let me take 2 coordinates, third coordinate. This I am taking x, this one I am taking y, this is z. And if you want, then you can interchange also this thing. Nothing, not want it won't change. So for defining this one, so for that one, if we were taking 2, then there were no issue. We could have taken. But if I define 3, 4, then let me give an example. This coordinate I can write y, z, x. I can write. Means maybe y we are taking 3, you will get y you are taking x, it may come down also. Y you are taking y direction here, you can go this direction also. You will get perfect. So for that one I will say I am telling that how to show that direction. So there is one trick. We can write x, y, z. Connect it like this. What is that means? I can write x, y, z. So if I am taking any coordinate, let me take these 2 coordinates when we were taking about 2D motion. So I was taking x and y. Let me take it y or z. Okay. So for this one, how can I define? What should be the direction of our x-axis? For defining, what can I do? What will I do? I will use my right hand and I will take my finger to the y, because y is coming before. Or you write it, you can use y to z. Y the arrow mark is y to z, z to x, x to y. So here I am taking y because y to x, z. If I could have taken z, then I had to go for x. Okay, x to z to x. But there are my 2 coordinates I have taken x and y. So I will take my fingers to the y, and I have to make turn to z axis. But this type the direction fingers are not going. So what I will do, I will rotate it like this, and now I will correct. So my thumb is going to show the direction of x-axis. So according to this thing, the direction of x-axis will be like this. Similarly, let me take another example. If you sometimes what happens, usually we get confused. So for this purpose means it will make us or be quite easy to set the direction. So let me take this time x or z direction. So now what I want to do, I want to show the direction of y-axis. So there is x-axis, z-axis. So here our combination is z-axis. So here who is going to here? Z is going to x. Yani I will keep that finger in z direction and I will rotate that curve to x-axis. Right? So now once again, you may also get confused that why I am not rotating like this. If I rotate curly, then also it's coming. Means if I rotate this direction, then also. But thing is that when I rotating that this angle should be not more than 180 degree. It should be less than 180 degree. So here in the, we are getting 270 degree angle. This is 270 because 90 degree, 90 degree, 90 degree. So if I move this direction, so this is 90 degree. So we will go with that direction. So if I want to show, I will keep my finger this side and I will rotate that curl it to the x. So my thumb is showing to the direction of y-axis. So this is the direction of y-axis. So I think now you understood. Then let me check is it correct or not. Now what I am doing, let me see that for z-axis we will see. This is y, this is x. So two axis is given. So I want to show the direction of or axis, draw the axis or z-axis. So for that, so x and y coordinate I am taking. I want to draw the z-axis. So for that, I will keep my finger to x-axis and curl to the y-axis. So I kept my x-axis, that finger to x-axis and curl to y-axis. So the z direction is like that. So our taken coordinate was correct. Now we will see what defining the. So actually, if we see in 3D that what is the position of particle here, it is like this, somewhat like this, and particle position is somewhere here like this. So first what we will do, we will see that actually position of particle is here. We will say that consider that it is in 2D motion only. We will that z-axis, this axis we will forget about it, or other than we will forget about this particle is there, but I will consider that this particle is in this xy plane only. That is not there. So for that, how can we solve? So first we will solve that according to 2D motion we know how to solve or show a position of a particle. After that, what we will show that version we will consider or we will move it to 3D. Means after solving the position of a 2D, we will make it 3D. So let me take my particle position is here and it is in xy axis. So according to the xy axis, this is like this, and I can show this is r vector. So this is x1, y1. So if I want to show the position of particle in this accordingly, so it will be according this one. I can write one equation using Pythagoras theorem. What is that? I can write it like this. This is y1 equal to, so I can write r square is equal to x1 square plus y1 square. Correct? On r is equal to, I will get x1 square plus y1 square root. So this is, and similarly if I want to give theta here, then I can write x1 is equal to r cos theta and y1 is equal to r sin theta. Now I know that r is equal to x1 square plus y1 square root. So let me show it again once. So let's see that this is my x-axis. This is z-axis. This is x-axis and this is y-axis. So if we see here, the actual position of particle where it is here somewhere in 3D. So it's like here, you see. But what I am doing, I am considering that z-axis is 1, z-axis is 0, so particle is here. So it is in 2D motion. This axis is not at action now. So for this one, what we can define that r1, y1 is equal to all these things. R we can define. So now what we have done, this r value of r we know that root of x1 square plus y1 square, and if I make it actual position of particle is here. So let me take the position from particle here to here. This distance is k. Okay. So this is k and this distance r I know. And what is that? This distance is equal to this one, same only. So what is that? This distance I am considering that z1. So what we can write like we can make this is my y1, this is r, and not r, that is k, bigger, and this is r. So according this, and theta we will consider here. For theta you should be careful with, or for considering theta. This is y-axis, z-axis, z-axis. So theta for that we will consider from k to k and that k vector and x-axis, z-axis. So it will theta will z and k. So here what is this? What is here? That is z1, this one and k. So sorry, I have made theta not theta. That angle we will consider between z1 and k. That is angle is phi. So now we can write, if you want to find that relation between k and r, z1 r, z1 k. So we can write z1 is equal to k cos phi and r is equal to k sin phi. I think now you understood. So this value we found from here. Now that r we have considered this value, because these four comes, why we take r? Because I have taken that, considered that once a particle is xy plane, or for that this distance will be r, that is taken r. So this value, if I want to find the value of x1 and y1, what can I do? I will replace that x1 is equal to x1 is equal to r cos theta. So r is, what is r? R is k sin phi. So here then write k sin phi or okay. This is now we have found value. So k sin phi and x1 is equal to r cos theta. Similarly, y1 is equal to, if we consider that sin theta, so r is equal to k sin phi and sin theta. So now we have taken x1 value we got, y1 value we got, z1 value we got, and common value of k if we see, that will be equal to the root of z1 square plus r square and z1 square x1 square plus y1 square. Those r value is x1 square plus y1 square root. So this way we can find the coordinate. So this is the thing. This was the basic thing we have learned today. So this one we will finish today's class. So if you want to move into the next video, so after getting the video ready, we will keep the video link in description, so you can go direct on next video, move to the next video. So thank you. We will meet in next class.